Real zeros of polynomial functions. The function f has at most n real zeros. The graph f has at most n minus 1 terms. So depending on your degree tells you it has at most that number of zeros, and you will have n minus 1 turning point. So an example is if I said it was the power of, let's say, x to the 7th power, that means you have 7 real zeros, possibility of 7 real zeros, and at most 6 turning points. When f is a polynomial function and a is a real number, the statements listed below are equivalent. So this is how you would write these. When we're trying to find zeros, you write x equals a, or even solutions, it's x equals a of the polynomial equation. Then we write them as, if you want to write it as a factor, you leave it in that form. Then if it's asking for an x-intercept, we write them as an ordered pair. So these were finding all real zeros, so we're just going to write the answer as x equals. So we're going to determine the maximum number of turning points on the graph of the function. So finding the zeros, meaning we're finding the x-intercepts, is basically what we're doing. So all you're doing is you're setting the equation equal to 0 and solving. So we set it to 0, we can factor out a 2x squared. So we're left with an x squared minus 1. So we can factor it. And so that we know our x's are at 0, it's at plus and minus 1. And if we have to write it in x-intercept form, then that's when it says 0, 0, negative 1, 0, and 1, comma 0. The maximum turning points is 3. So try this example here, find the real zeros, then determine the maximum possible number of turning points of the graph of the function. So in this case, our zeros are at 0 and 6, and it has a maximum of 2 turning points. And note, in example 3, note that the factor negative 2x squared yields a repeated 0. So the exponent is even, so the graph only touches the x-axis at x equals 0. Okay, so it doesn't cross, it touches it. So a factor, x minus a raised to the k, when k is greater than 1, yields a repeated 0, or x equals a, of a multiplicity of k. When k is odd, the graph crosses the x-axis at x equals a. So think about when you have like an x cubed or just an x, it passes through. Then if k is even, the graph touches the x-axis but does not cross the x-axis. So it bounces off of it at that point. Think about your x squared. So when something is raised to x, when something is x squared, that's a quadratic, it bounces off of the vertex, for example. So just to re-emphasize, anything with an even power is going to bounce. So x to the squared, x fourth, it's going to bounce. When it's odd, it's going to cross the x-axis. So we're going to sketch the graph of this polynomial function. Sketch the graph of f of x equals 3x to the fourth minus 4x cubed. So we're going to take a look at the leading coefficient test. Then we're going to find the zeros. And then we're going to plug in some points to find just some more pieces of the graph. So we know that it's raised to the fourth power. We know that the ends are going to go up and up. It's positive, so they're both going up and up. And then we're going to go ahead and solve for the zeros, or x-intercepts. So we set it equal to 0. We can factor out an x cubed. So we have 3x minus 4. So we know that our zeros are at 0, and it's also at 4/3. So 0 and 4/3 is here, and we can plug in some points. So if I plug in 1, that's 1 times 3 minus 4. So it's 1 times negative 1, or negative 1. So at 1, we're at negative 1. And so we can go ahead and sketch our graph. It does something like this. Okay, we could plug in more points to figure out more of what it does, but this is a good general sketch of the graph. So go ahead and try this example here. So we notice that when we find the zeros, we have 2x squared, parentheses, x minus 3. So it's really important to look here. This is an x squared. So that is a repeated root and even. So I know that it's going to bounce at x equals 0 at somewhere, either up or below it. Now x minus 3, that is a 0 as well. And it's a pass-through because it's an odd degree. So I know that about my graph. I know the end behavior. It's odd, so it's opposite. So it goes up on the right, down on the left. I plugged in some points. I plugged in 1, I would get -4. Plugged in 2, I would get -8. And then I would get -1, I would get -8. I'm sure if I plugged in 4, I would get a value that would be in the positive. So here is a sketch of this graph. Let's sketch a graph of this polynomial function, so just a little bit more practice. We're going to sketch the graph of f of x equals -9/2 x plus 6x squared minus 2x cubed. So it's helpful to remember that we need to write polynomials in standard form, meaning that the highest power should be written first and it goes in descending order, just so we don't, accidentally make a mistake in our end behavior. So this goes -2x cubed, so let's set it equal to 0 already, -2x cubed plus 6x squared minus 9/2 x. So that's the first thing you should do. So in this case, we have this half here. So what I'm going to do is I'm going to factor out a -1/2 x. Essentially, when you're doing that or one way to think about that is that you're multiplying 2 to everything in order to cancel out the denominator. So notice what I get is positive 4x squared minus 12x minus 9. Okay, so again, it's like you're factoring out a -1/2, but one way that I think about that is that I'm multiplying a 2 to everything. So then let's find our zeros here. So this is going to end up being 2x minus 3 times 2x minus 3, as that's how it factors, or -1/2 x is 2x minus 3 raised to the square. So our x values are at 0, or our zeros are at 0 and at positive 3/2, and at 3/2 I know that's a repeated root, so I'm going to bounce in some way. My leading coefficient tells me that it's odd and it's negative, so I know that it's going to go up on the left, down on the right. So plot the 0, and then 1.5 is about here. And I know that it bounces at 3/2. So if I know that this is my graph, looking at 3/2, it's going to bounce here. So I already know that. And then I know it's going to pass through here. I can almost pretty much, sketch my graph at this point. So let's plug in 2 because I have this 1/2 in the front. So let's plug in f of 2. I get -1/2 times 2 times 2 times 2 minus 3 squared. So this will be -1 times 1, so that is -1. So at 2, I'm at -1. And, I'm sure I could pick some other points as well, but I think this is okay for now. Okay, this gives me a general sketch of this graph. So go ahead and try this example here. Sketch the graph of f of x equals -1/4 x to the 4th, plus we have x to the cube minus 9/4 x squared. So try it out. When you come back, I will have the answer for you. Okay, this is the graph that you should have gotten here. So the zeros you would find are at 0 and 3. So I factored out a -1/4 x squared. So again, yes, you divide out the x squared. And then I think about when I factor out the -1/4, I'm multiplying forward each term. And so we know it bounces at both the 0 and at the 3 because they're both raised to the square power. It's negative leading coefficient, so therefore the ends both go down. The end behavior both goes down. So I know it bounces at these points. Then I just check a point, so I know that these are some points that I checked out. So this is about the sketch of my graph, and so I hope that that helps out. The last thing is the intermediate value theorem. And so basically what that tells us is that if you have a point, if you test a point on one side and here, and it's negative, and the other point is positive, that means you have a 0 in between those 2 points. Okay, so we're not going to use that right at this point, but it's something that we will definitely use in the future. Thanks for watching.